Today, we're going to take you on a journey to a place so cold, so empty, so incredibly strange that it challenges our understanding of what it means to be cold. We're going to answer a question many people have wondered at some point. What is the coldest place in the universe? Now, when we think of cold, we usually think of winter mornings, icy winds, or maybe the cold vacuum of space. But space, while cold to us, is actually not the coldest place there is. The average temperature of space, the vast nothingness between the stars and galaxies, is around 2.7 Kelvin. That's about minus 270.45 degrees Celsius or minus 454.81 degrees Fahrenheit. That's cold, unimaginably cold, but not the coldest. The coldest temperature possible in the universe is called absolute zero. That's 0 Kelvin or minus 273.15 degrees Celsius. At this temperature, atomic motion stops entirely. It's the bottom limit of the temperature scale. But here's the thing, absolute zero doesn't naturally occur anywhere in the universe. You can only get close to it. So where in the universe can we find something that comes closest to this ultimate cold? The answer may surprise you. The coldest known place in the universe is not in some far-off galaxy or deep in intergalactic space. It's actually inside a laboratory right here on Earth. Scientists have been able to cool small clouds of atoms to within a fraction of a degree above absolute zero. These experiments use lasers and magnetic fields to slow down atoms to almost a complete stop, creating what's called a Bose-Einstein condensate. But of course, that's a controlled environment. Out in the natural universe, the coldest known place is something called the Boomerang Nebula. It's located about 5,000 light-years away from us in the constellation Centaurus. This strange and beautiful cloud of gas and dust has been measured at a temperature of just 1 Kelvin, only 1 degree above absolute zero. That is colder than the background temperature of space itself. How is that even possible? Well, the Boomerang Nebula is a dying star in its final stages. As it sheds its outer layers, the gas expands at an incredibly fast rate, cooling as it spreads out into space. It's like when you spray compressed air from a can and the can gets cold. In this case, the gas is expanding so quickly that it cools below the temperature of the cosmic microwave background, which is the leftover heat from the Big Bang. To give you a sense of how cold that is, imagine standing in the middle of Antarctica during the coldest night ever recorded. Now, subtract hundreds of degrees. That's the kind of cold we're talking about. But let's go a bit deeper. Why does temperature matter so much in the cosmos? Temperature tells us how much energy something has. High temperatures mean high energy, atoms moving fast, light shining brightly, nuclear reactions in the cores of stars. Low temperatures mean low energy, atoms barely moving, matter settling into its quietest, most peaceful state. The universe began in a hot, dense state with temperatures unimaginably high. As the universe expanded over billions of years, it cooled. Stars were born, galaxies formed, and planets appeared. But in the vast stretches between these islands of light, temperatures kept falling. Today, the cosmic microwave background gives space its average temperature of 2.7 Kelvin. But regions like the Boomerang Nebula can dip even lower due to the physics of rapid gas expansion. And yet, even the Boomerang Nebula isn't the coldest place humanity has ever encountered. As I mentioned earlier, right here on Earth, scientists in advanced labs have created temperatures as low as a few billionths of a Kelvin above absolute zero. In 2017, researchers at MIT cooled sodium-potassium molecules to 500 nanokelvin. That's 0.05 Kelvin, practically absolute zero. But this brings us to a fascinating point. Why do scientists even try to reach these extreme lows? What's the point of creating such cold conditions? The answer lies in the laws of quantum mechanics. When matter is cooled to near absolute zero, it begins to behave in ways that defy our everyday experience. At these temperatures, particles lose their individual identities and behave like waves. They can occupy the same quantum state, creating entirely new forms of matter. Understanding this behavior helps scientists explore the fundamental nature of reality, leading to breakthroughs in quantum computing, superconductivity, and our understanding of the universe itself. So, when we talk about the coldest place in the universe, we're really exploring two stories. One is the natural story, the Boomerang Nebula, a cosmic artifact revealing the strange and beautiful ways stars live and die. The other story is a human story of how our curiosity and intelligence allow us to recreate the coldest conditions possible right here on Earth. But I want you to think about something else. When we talk about cold, we're also talking about emptiness, stillness, and the end of motion. In some ways, the coldest places in the universe remind us of the ultimate fate of the cosmos. Scientists predict that in the far, far future, trillions of years from now, the universe will continue to expand and cool until all motion stops, and the universe reaches what's called heat death, a state of maximum entropy where everything is evenly cold and empty. That's the big picture. But here we are, right now, alive in a universe full of energy and motion. Stars still burn, planets still orbit, and life continues to thrive. In a cosmos that will one day fade into cold stillness, our existence is a miracle of warmth, movement, and light. So next time you step outside on a cold night and look up at the stars, remember this: the coldest place in the universe isn't out there beyond your reach. It's a story of dying stars, expanding gas, and human curiosity. It's a reminder that even in the coldest corners of the cosmos, there's something worth understanding, something worth exploring. Thank you for joining me on this journey to the coldest place in the universe. Keep looking up and keep wondering. The universe is full of incredible stories, and we've only just begun to tell them.